Assalamualaikum warahmatullahi wabarakatuh. Uh, First, let me introduce myself. My name is Ananda Nursena. My matrix number GE2056, and my friend Virshal Doriski Purnomo GE2000. I will present the result of project segment 2 with my friend, where we are from group 9. And we thanks to Dr. Rozali and Dr. Afida who have given us knowledge. In this project, there are three tasks. Task 1 is design your own CNN models to train the data without overfitting or underfitting. For every process, record its outcome and eventually analyze its performance. Task 2, by using transfer learning concept, repeat the training process and find the optimal model. You are given an image as shown in figure 1 and you need to investigate a suitable method that able to identify and count the recyclable material in the image. Next, introduction. Convolution neural network. Convolution neural network or CNN is a type of neural network commonly used in image data. This is a different from artificial neural network. CNN can be used to detect and recognize objects in an image. Broadly speaking, CNN is not much different from the usual neural network. CNN consists of neurons that have wake, bias, and activation function, as we have learned in the previous section. This is an example from CNN network, a step by step from CNN network. Previous artificial neural network has input layer with input neuron, hidden layer with hidden neuron, and finish artificial neural network is output layer with output neuron. This step for artificial neural network. Uh, Different with CNN network. CNN network with uh, step from input layer we have convolution 1, convolution 2, and convolution 3, and set epoch size and iteration per epoch setting by yourself, myself, and my group self. Epoch in the example is 10, but size is 100 to 20. Iteration per epoch is 4069. CNN network have a convolution 1, convolution 2, and convolution 3 with filter and max pooling. Nah, in convolution and pooling is to type for future learning. Convolution neural network uh, have a step by step to have output. First, input and future learning and classification, and next, finally, is output. First input, and this is a future learning uh, value, convolution plus ReLU, pooling, convolution plus ReLU, pooling. This is a step for future learning. Future learning have a 1, 2, 3, or step for perform encoding of an image to features in the form of number that represent the image. And feature learning have two. This is a convolution layer and link layer. So this is a convolution layer. This tree filter will be saved to all parts of the image. And this is a example to figure convolution layer. First input tiles, second small neural net, and third output array. And this is a process to have output array, output volume. Convolution layer. Three filters will be saved to all parts of the image. Each shift will be cleared of dot. This is a dot is multiple operation between the input and the value of the filter so as to produce an output, or commonly referred to as an activation map or filter map. Uh, the filter map generated from the filter extraction is still in the form of a multidimensional array. So it must flatten or reshape the filter map into a vector so that it can be used as input from the fully connection layer. Fully connected layer is usually used in the multi-layer perceptron method and aims to process data so that it can be classified in output volume 3 multiple 2 from input volume 7 multiple 3. And to a pooling layer. The purpose of using the pooling layer is to reduce the dimension of the filter map or downsampling, thereby speeding up computation because fewer parameters need to be updated and overfitting. Uh, and to this is a example to pooling layer. The most common from the layer pooling is to use a multiple two filter. This is an example from single depth slice from 4 multiple 4 and result to multiple 2 filters and straight 2. Pooling layer have two type. One is max pooling, two is average pooling. This is a object. Object in this project, we sorry we training data with two type training data, PGG and ResNet, PGG 16 and ResNet. And this object from sample image, I have two type of object, namely is bottle and tanks. The object data of each object is taken with three conditions. One, we take a photo side by side in first photo. And two, from the position one, we move the bottle about 10 or 15 centimeters from the position of the can. The condition of the third. On the third picture will be same as the second. Only this time the can will be in the back and the bottle. For about 10 or 15 centimeters. Mm. Data data set that we use for object for the object is 1199. Epoch is 15, size is 20, and iteration per epoch is 24. Data for the class we use are two. This is a bottle and cans. Data from the two classes is divided into two types of data group, namely one training data and two validation data. The division of the data groups for training process is 70% and validation process is 30%. The purpose of this object is to compare the result of the data above with the data that has been obtained. Hmm. From the CNN layer, network parameter, sample data 1199 data have two tab. One is training data and two validation data. Validation data is data that is not used in the training process. If the accuracy of this validation data is not good, overfitting may occur. Therefore, the network needs to be modified again. So, in this project, we modify back will I have data training and validation accuracy is so good. From several explanations of convolutional neural network and objects used in this project, we have obtained the result and conclusion that will be explained and demonstrated by myself. This is a example to demonstrate. This is a demonstration by my friend. So, thank you for the presentation me. Uh, Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Wabarakatuh. Let me introduce myself. My name is Firshalo Rizky Purnomo. My matrix number is TE20002. And before I take a presentation, I said thanks to my friend Ananda Nursena for the presentation before. Okay, in here, okay, wait, I go to slideshow. Okay, in here I will continue the presentation from my friend Andre Nurjana, and I will demonstrate sample data on Google Colabs. And I want to show how produce this graph training and validation accuracy, later on training and validation loss. Okay. The first step is to upload the data set on Google Drive. In here I have many sample data, and